Hello everyone, I'm Gareth the Master 974 back again today playing SpaceEngine on PC. Now, hopefully this is coming out okay. I have altered my graphics settings a little bit compared to last time, though I really don't know if this is going to be coming out okay. Mostly due to stuff like anti-aliasing being on, but basically last time I played this there was some dropped frames throughout the experience. And hopefully it's not happening now. It does look like it drops a little bit of frames, but that's usually going in and out of the game. So I'm going to try and continue it today. Now, one thing I've gone ahead and done is actually uninstalled all of the planets of our solar system HD pack. Well, it's actually multiple packs, but this is supposed to free up some hard drive space on my end. And we actually have like this blur effect going on in the background. And I find it funny there's actually an asteroid named Shakespeare, so I looked into that. But one thing I realised last time was if you look in the bottom left, we actually have the functionality to progress time. So as you can see, there might actually be a very slight rotation to this, but if we fast forward time, then there's definite noticeable rotation. Now what we can do is actually increase the speed of our spacecrafts to something massive, and then we can actually see the planets of the solar system. And if we increase time, then the sun is actually like rotating itself, and we can actually go down here and go track object, I believe it is it this one? Center an object, there we go. I think I said the sun. Oh, well, it must be the stellar baryocenter or whatever they're calling it. But yeah, we can just look at it, and then hopefully what should be happening is we see the sun, and we can see all the planets going around it. And if we really wanted to, we can actually go to a planet like Jupiter. Yeah, and then if we go to the object, there we can actually see the orbits of all of the shit. I didn't select this, but anyway, it's supposed to show all of the orbits of the moons around Jupiter as well. It's a bit confusing when you set the time this fast, so let's just slow it down some. And let's increase our speed quite drastically again to escape orbit of this mysterious object that we just got to out of nowhere. And as you can see here, we got Jupiter, which we've already been to in the past, spinning on its axis, and we have all of the moons around it as well. Now we have labels, so as I said, Io is not the closest moon, but we have other more closer moons to the surface of Jupiter here that are whizzing right around. And similar with like Saturn and all the other planets of the solar system. If you go right the way out, then you can even see Aries right the way out here. And whoa, it's going at light years per second for a moment. But yeah, so all of this I've done before. I just wanted to show you the fact that there's time progression, and there's also orbits as well, so you can view the orbits of the planets and moons around the planets as they go around the sun. And another interesting thing that you can do as well is if you go to our search functionality here, then I did this last time as well. We went to Sagittarius A star, which is the supermassive black hole at the center of the Milky Way galaxy. What we can end up doing is actually doing the same sort of temporal progression that we've done at our solar system, and see the stars whizzing around the galactic center. So again, we're gonna have to, increase time massively, but if you do it, then you can kind of see all of these stars whizzing around, which is quite beautiful. In fact, I'll try and make something like this a BRB. If I ever go into like live streaming and all that, I could set something like this as a video clip to play as like a BRB thing. But just give you guys some perspective of the range that we're talking about here. Yeah, quite a lot of stellar orbits around the center of the galaxy. So one other thing I found as well is you can actually go under this. There's like a journey. There's locations, and it gives you a list of locations that you can go to. So you can go to the Pleiades or see the Pleiades. There's a micro quasar. But one thing I find interesting as hell is actually the very first imaged black hole system, which is going to be around here somewhere. It is, of course, not even here now. What the hell? Well, my locations. Yeah, it was here. I swear to God, it was. It says that, yeah, this one. The first black hole imaged. You just go to that. Did I just click on the wrong thing? No, okay, I didn't. This is the first black hole that was imaged, apparently. One thing this does is actually turns like all the stars off and everything else. You can still see the orbits, but you can't see anything else. And one thing I find really interesting as well is take a look at something like S25. See the label? It actually, well, where's a better example actually? If you look at it in a certain way, you can even begin to see, you see the label like warping, and that's the black hole doing that. It's actually really interesting. So this is like what a black hole would look like. If you go out, then it just looks like a galaxy most likely. But you go further in, and then you really begin to see the black hole in the center, which is actually really cool, I think. So maybe something like this can be seen at Sagittarius A star in this if you go to it. But it's interesting to get to see a black hole. But of course, turns all the other stuff on, even off. Sorry, turns all the stuff off, even though it's still technically on. So I don't know what that's all about. But we can also go to other places I've not been to. That's just a summary, I think, of places we've been to. I just clicked on it again. How about, let's see, the Andromeda Galaxy, why not? Our closest galactic neighbour. Here it is. Don't look this way, there's nothing. That's probably, oh, now there's galaxies that like spawn in out of nowhere. But you got a star over here. And that's probably our galaxy, isn't it? The Milky Way, or that's why it's Triangulum, excuse me. Don't know what I'm talking about. But, and also what I can do is rotate around as well. So you get to see this. And I don't think this is going to be as comprehensive as the Milky Way galaxy, though it might be. I mean, we can go to like star systems in Andromeda maybe. But you know me, I'm going to go right into the very centre here and see if there's anything. Like what the name of the black hole at the centre of the Andromeda galaxy is going to be to actually go to it. But we're going at like killer light years per second, which is why we're zooming around really quickly. But we can go to a lot of different places if we really wanted to. Hell, this might as well be the galaxy that we're in, as far as I'm concerned. But yeah, you can just go around, explore star systems if you want to in another galaxy. You can go over here to whatever this bright galaxy is and go anywhere else. So let's go somewhere else and then try and find some other places to go to and go from there. Let's see. Binary molten planet. Let's give this one a look. A look-see. So as it loads up, what we'll see is something. Don't know what it's going to be exactly, where it is. But this is Gruis, I think. And 2B and 2A. Now, oh, that's got to be. This is either the star or that's definitely the star. Look at that. It's like got cells and all that. So that's the star over there, and this is like the planets. It's actually, yeah, it's a binary planet system supposedly, but yeah, it's molten because it must be very close to its parent star. And you can actually land on those kinds of planets as well if you really want to. There's other systems as well. And you might be wondering what the hell's going on with all the blooming and all that. That's actually the photo mode that's actually selected. So I think for me, I like to put it on HDR mode, which should look a little bit like this, so it doesn't bloom so much. But yeah, and then you can see all the stars as well. So if you're seeing stuff like this, I think that's actually the game lagging on me, not the actual video. But we can go to other places as well. We can try and go to other places in this system, but we're not really going to do that. I mean, we got this molten planet here. We can crash land on the surface if we really want to, and it looks all like shit. Literally like shit. But see where else we can go to. Obviously, galactic monsters, the center of the galaxy. So if you want to see a SGI star, you can click on this one and you go there. There's a TRAPPIST system, for instance. So this has been a pretty popular system, as there's been a lot of exoplanets detected around it. So you might be wondering how exoplanets even get detected to begin with. And so it could be the fact that the star wobbles a little bit, and because of that wobbling you can determine what planets are orbiting around it, or the fact that there's light intensity drops, which means that the intensity of the light that the telescope in this case is going to detect actually decreases slightly by like a handful of percent or something, and you can use that to determine what must be in the way of the star to allow that to happen. So you can see it's like a rocky mountainous world, this Mars-like planet. TRAPPIST 1 in this case, or 1E, and you can actually move in a lot closer, so I can do my travel at incredible speeds again and go to other planets. There's 1E, 1F and all that. I can go to 1D for instance, and see that it's a somewhat gaseous planet, is it, or whatever. Oh god, I'm doing head spins today, ladies and gentlemen. What the hell's happening? Okay, walking on the surface. It must be just an atmosphere, maybe, or the fact that it is just a very dark planet or something. Yeah, definitely an atmosphere. Cool, let's go. Let's explore. These planets aren't going to explore themselves. One of these is like supposedly Earth-like, to be honest. 1C looks somewhat similar. There's 1B if we go even closer, and I think this is because it's a red dwarf that these planets can actually exist a lot closer. So in this case we've got a warm mini Neptune, so that's probably an ice giant, but it's close in, so it's going to be very hot. Where would 1A be then if this is 1 and the closest thing is 1B? You'd think 1A would be somewhere, unless it's like really close up to the star and you don't see it, but you'd see the orbit though, that's the thing. Could go even further out, or 1H for instance, all the way out here. And as you can see, 1H is just another somewhat gas giant, or Venus-like planet. Cold, arid Aquaria. So there we go. And we can just zoom on out and fly through the universe if we really wanted to, but fuck it, takes too long. I got Pluto, New Horizons Departure, Kepler 452b, the Rubber Ducky Comet, Io. So most of these are places we've been to in the solar system. I might not have been as complex as I was. We can go to M74 for instance, which is supposedly the perfect spiral, and I might have to, okay, and then travelling at kilo light years per second, but still you can look at all the other galaxies in the system and really begin to explore this system if you really wanted to, and go from there. Just go all the way through and see what there is to offer. So pretty interesting, I think. So being able to see all this stuff, go to other planets and star systems in other galaxies and all that, and seeing other galaxies as in themselves. It's actually pretty cool, I think. So this is something you can do if you really want to, is actually go to these systems and Let's finish this little bit of exploration off with WHG64, which is the biggest star known. And as you can see, we got the galaxy in the background. It's actually the Milky Way galaxy. So this is a really big ass star supposedly. I think it's on the right mode, but it doesn't even look spherical. It just looks like a big clump. But it's got 19 solar masses apparently. So see, so it must be like, you know, not that dense if it's going to be very large. But what was this? Planet number 1 apparently. So yeah, you can actually click on the star and do the solar system browser thing and go to these planets, or even, you know, planet systems. That's the game doing that, by the way. I think this might actually be a binary system, or it's just a planet and a moon. Interesting to see this sort of stuff, to be honest. Whoa, look at that. That's a giant sun right there. That's the comparison thing. I didn't want to click that. I can go to number 3. So we zoom right the way out of this, and we go right the way here, and we see this molten world. It might tell you about the planet's surface as well, the temperature there. 921 Celsius. Fuck, that's hot. What the hell's wrong with this one? 1000 degrees Celsius? Seriously? Like, you wouldn't think a planet like this is supposed to be this hot, this far out from the sun, but number 2's the worst. So it must be because they have like atmospheres or something, because you might wonder why Venus is the hottest planet in the solar system. That's because it's got a thick atmosphere. So it's a greenhouse effect where any of the heat that comes in gets practically trapped and it heats the surface up. But we got 2D2 right here that I'm going to, which is just a smooth looking rock orbiting around it for some reason. It's just a very, very smooth rock. And again, you can still see the passage of time, so this is what's going on in this system at least. So yeah, very, very hot system, let's say that much. And then of course you can go into the information as well. So it's a red supergiant, which is, well, it just gives you all the information about it as well, like even metallicity, how much metals there are in the star itself. And yeah, even though it might be the biggest star, it's only like, you know, got 2600 degrees Kelvin. That's the apparent surface temperature, yet it must be, you know, very, very, very hot, to say that much. So let's go a bit closer to home. Let's see about, well, I'm sure there was one on the Earth, wasn't there, somewhere? There's a blue rings planet you can go to. Binary molten planet, I think we've already been there. Kepler 452b. Io, the moon, for instance. Alpine Valley. Icy moons in a sextuple star system. Yeah, let's have a bit of that, man. Let's have a bit of that. So that means there's going to be 6 stars in this system, which is unbelievable if you ask me. It could happen, but I find it hard to believe. One of them could be flung out. You never know. But if it looks anything like this screenshot, then that'll be pretty cool. Even though it looks pretty low res. Oh, it does look a bit like it. So you can just go around. You can kind of see the reflectivity on the surface as well. So some specularity going on right there. Race around the surface of the planet. But again, we can go to the solar system viewer, and you can go to, okay, so we got the A and B barycenter, which is the, essentially that's the center of gravity between A and B in this case. So they have a center of mass, you know, because it's going to be a binary star and all that. So then we can go to the B barycenter, which is on the other side. So these are stars that are orbiting around each other. And bearing in mind these are two stars like orbiting around each other, it does look like it's pretty damn cold out here. Again, it might have changed the picture mode. No, I don't think it has. But yeah, if you see the blooming going on, that's probably what it is. But yeah, a nice star system with 2 stars going around each other and probably another 2 stars going around that as well. So that's like the entire system. And you can zoom right the way in and see what's really going on here. You can go to like number 1 as well. Should be at the very forefront of all of this. And yeah, I think this is where we started, and we got the moon around that as well. So pretty cool if you ask me. And it's probably not going to look as good because I got rid of the HD texture packs and all that, but it's starting to look a little bit better, I think. But again, that's the game now dropping frames, not me. I've got to point that out before people think, what the hell is this? Can I click on, can I even click on this? The Large Magellanic Cloud. You know what? Let's go to. So here we go. In the grand scheme of the universe, we have to travel at killer light years per second to even do anything. Now, one thing I can say, it looks very two-dimensional, to be honest. Maybe it's because I'm not really getting close enough to it. But yeah, that's the thing, is that most of what we actually would see in the universe is actually fairly two-dimensional, because it's just the way we see things. So yeah, these are 3-dimensional objects, but we kind of see them in only 2 dimensions realistically. We can see Andromeda over there, we've got Triangulum, and I believe there's the small Magellanic Cloud around here as well somewhere. But what was I seeing around here? Oh, this is something nice. A red supergiant star. So these might be stars in this galaxy as such. This is what I was seeing. These are like all the other objects we're seeing, which could be other galaxies in the universe. And you could just go from one place to another and just go and explore the universe, which should be pretty cool. So where did that Triangulum get to? But it doesn't really matter. Just go to the Milky Way. We can go here. Oh, we don't even go to it. It's just like, yeah, here we go. Yeah, okay. And that's the thing as well. When you keep dragging around like this, you kind of, you know, like rotate as well. So that's what it feels like, at least. Yeah, there's a small Magellanic Cloud over here. Yeah, you can definitely see a lot more stars now. This is pretty awesome, let me say. And you might not even believe it, but most of the points that you're seeing here are actually galaxies. Light years and light years away from where we are. It's actually pretty cool if you ask me. And it is what it is. At the end of the day, you can travel at killer light years per second if we really want to, maybe even mega light years per second, and really begin to explore these the galaxies and actually go to them in like real time or whatever. And then there we go. So now what to do? Let's see. Micro quasar, why not? So I am going to regret saying this, but I did a module at university called Quasars and Cosmology, and that's going way too fast. Let's just slow. That's supersonic fast, that is. Hold on, just please slow down a little bit. Okay, so I did a module called Quasars and Cosmology, and part of that was obviously talking about quasars. Now, quasars are essentially a type of active galaxy. So an active galaxy is a galaxy that has a supermassive black hole at its center, and it's actively eating material, if you will, that, and then it causes this emission of energy. So that's kind of what is going on here. And I think this image is actually how we see it from Earth. This is how we would see it. And then if we look here, this is how SpaceEngine actually interprets this object. So what the hell did I do to just like go down? I didn't even do anything. But as you can see, there's this star in the background as well. And the star itself is actually, you know, like getting distorted due to the black hole, which is actually really cool to see. That's something called gravitational lensing at work right there, which is predicted from general relativity. So it's great to see something like that actually in this game, or in this emulator, or whatever you want to call it. I'll actually just change. Oh my god, okay, don't change it to HDR because that's like impossible to see. But then if we zoom out of the system, then we see the star over here. Is it still going to be really bright? Yes, it is. Yeah, okay. Manual. How about manual? Well, yeah, that's the thing you see. Is yeah, quasars are very luminous objects because of the amount of energy that they would be emitting. So they'd be really bright. I mean, this could be, you know, light years and light years away from the Earth, but we can see them. Like, I'm talking, you know, it's like megaparsecs. That's like a million. So you're probably talking like 3 million light years away or something potentially, and we see it because of how bright they are. Pretty insane to think about, if you ask me. So what's this? Sometimes I get a little scared looking at this stuff because I really don't know what the hell to expect from it. But that's like the star as well, and that obviously has something called the barycenter, which is the or you know, like the center of the orbit. So this must be a big ass star then. It looks pretty big. Of course, we can do this scale comparison as well, and just like do something to shift it around. It could go based off of size, or based off of mass, based off of density, or temperature even, or just the system architecture, however you want to work it. And escape backs out of that as well. So let's see. Let us go to not the log, because I didn't even do that. Let's go for search now. So as you can see, we can type in anything. So I can type in something like Kepler, and it will look up all of the Kepler, Kepler stuff. And these are all like exoplanets. So Kepler 148, for instance, we can go there, travel across like the universe. I'll change it back to HDR actually, because then you can see. And yeah, we can actually just click on the solar system here, and then see the planets around this system. So we've got 148b, which would be very, very hot. Was that torrid sub-Neptune? 1000 degrees Celsius. Yeah, that's pretty damn hot if you ask me. Then we go to Kepler 148c. It looks like there's some gas or something around it, like some weird thing going on right here. And 148d apparently as well. So maybe A is actually the name of the star itself, and then it goes like BCD because of the exoplanets around it. And even here it's like 180 degrees Celsius, and you'd think it's pretty far out, but it must be pretty close. And that's something about exoplanets as well, is that most of the ones we see are actually big ones that are very close, since, as I said, a detection method is wobbling, and the wobbles would be pretty noticeable, because if you have a big planet very close, then that's what you'd see. So even if you go to something like 1500, for instance, then they probably have exoplanets that are very, very close, and they're going to be, you know, uninhabitable because they're so hot. Like here, for instance, this is like, whoa. Hopefully you saw that. But yeah, a torrid arid terror. So a rocky world that's extremely hot. 935 degrees Celsius. Yeah, life's not going to survive on this place, let me tell you. And this one, that's even further away, which is actually like 1,000 degrees Celsius. Oh, it looks green. It's not very often you see like green stuff in the universe. So it's probably got like an atmosphere, and the atmosphere contains, it even gives you like the composition. So it's got nitrogen, water, carbon and sulfur dioxide. So yeah, it would be a reason why it's actually hot there. Let's see, what else can we search for? I mean, you can't just type in something like black hole, because it doesn't even come up with stuff. It comes up with you know, like black widow, black eye, and it doesn't even have the type. So you can't even type in black hole and look for it. So it must have a lot of stuff in this database if it's doing all stuff like this. There's the Gillies system, for instance. There's, you know, Kepler stuff. Bunch of these are like from surveys, so they're all, you know, observations and stuff like that. So where could we go to? I mean, look at these creative names like SDSS. I think these would just be stars and not planets around them. We've got other galaxies to go to, and stuff. So I don't know what to do. I mean, I don't know how you would actually like find stuff like galaxy, sorry, black holes and all that if you wanted to, unless you knew the name of them to go to them, because I think they might classify them as stars, not black holes. So that would be some research for me actually, is to look into this stuff. But curving. Let's go to curving in our own solar system. An asteroid looks a little bit like this, and oh, it actually has a partner. S 2015 6384-1. So this is in our solar system. So there we go. A lot of these objects I didn't cover because they just weren't shown at all. But looks like I can cover them now if I can find them. What was one of these KIC objects, and it's one of the system where it's like they think there's a Dyson sphere around it. That would actually be pretty interesting to go to and just see if they actually done something like have a Dyson sphere around it, because that would be pretty interesting. Again, that could be for next time. How about we end with this ZWG 198.36, a galaxy somewhere in the universe, and there's all other galaxies in the universe. It's probably so far away you can't even see the Milky Way, but you can go here and again travel at killer light years per second and go in, and you see all of these stars in the galaxy. So pretty cool stuff if you ask me. Also, I don't know if you can see stuff like supernovae and all that as well. I mean, you can see like the remnants, like this thing for instance, this nebulae here, which is in this galaxy supposedly. But something like this is the remnant of a supernova explosion, and that's actually the game lagging out, so that's not me. But interesting to see if you ask me. That must be a globular cluster of stars that I just looked at. I thought it looked a bit interesting. And then woo, this is like light speed travel, and you see all the stars zooming right past you. Awesome. So, gotta love the music as well. The soundtrack's actually pretty good in this. Sets the right kind of tone for what's going on and what we're trying to do. Now, what the hell is this star here? I'm interested to see what this is. Oh, it's only a yellow supergiant. There must be a way you can identify the center of the system and just, you know, be able to go to it, because obviously there's supposed to be like a black hole in the center of every galaxy, so, or at least it's expected. Let's I kind of want to finish off the recording right now, to be honest. but I'll definitely tell you next time. I'll actually have some places in mind to go to in this and see what they've done with them. Earth. We've got to end on Earth. The one place we know of where there's definitely life, which is pretty awesome. Don't think I'm going to get as awesome of an image as I did for the first video, because that was pretty awesome, that image I took. That was a nice thumbnail. But yeah, this is a pleasant experience. If I could live stream this, I would, and if anyone would have suggestions of places to go to, that would be very nice actually. And then I could just like browse places and take a look and offer my physical insight into them, as lackluster as it may be in a live stream environment. But our beautiful planets, and of course we can begin to turn some of this crap off because it looks awful. HDR mode, and we can actually speed it up and see the Earth rotate from underneath us. So you can even see like the aurora as well in the back, just like around, just shimmering. And you might even be able to see the moon go around the Earth as well. Wherever the see, because that's going to be this brown. That's this there. You can see the moon. But yeah, obviously I talked about why the aurora come about in the previous part, and it's nice to see the street lights coming on in the day, the dark side of the planet as well. That's pretty cool to see. But I think I'll leave you with this. Seeing this happen. I have been Gaff, the Master 974, covering SpaceEngine again. Now, I do want to play this again, maybe even in a live stream environment. Just go to places, I'll look up places I think they're interesting, and go from there. So for now, I've had a good time playing this. Hopefully you have too. I've done some things and talked about some stuff that I missed on the previous recording. All I can really say is I hope you found this entertaining, interesting, watchable, enjoyable, whatever, educational even. But I'm going to be rounding this off here. So thank you for watching. Hopefully the videos come out okay. And I'll see you next time. So have a great day and see you later.